Good evening, everybody. This is Lorenzo Perella coming to you from Clark Wellman's Physics 116 class. This video will cover Lab 5 and covering the beat period of two pendula. In order to do this, we need to use the pendulum app from the last lab. And the essence of this is to determine the length of two pendula that have a given beat period and that we have to use a gravity of 9.81 meters per second squared as an acceleration. And then we use this application to confirm our suspicions. From this period, my name right here shows that I have to have a beat period of 8 seconds. Now, in order to resolve this, first you just come up with any length. What I chose was 0.85 meters. In order to get the length for the second pendula, I must first know that the frequency is 1 over the period, and the period is 2 pi times the square root of length divided by g. Now, I could go over all of this, but I found that my answers do not work with the simulation, so I had to redo my calculations, which are down here. Now I made the first one be 0.35 meters, and this is what we will be discussing. So in order to get the period, what we get is 2 pi times the square root of 0.35 meters divided by 9.81 meters per second squared. That gives us a period of 1.1868 seconds, 1.1868 seconds, and a frequency inverse of 0.84259 hertz. Now, in order to get the beat frequency of 8, that beat frequency is equal to the first frequency minus the second frequency of the absolute value. So we can also see that as 1 equals 1 over TB, which is the beat frequency that we are given, and that is 1/8. So 1/8 is equal to 0.84259 minus F2, which equals 0.125. And we find from equation that F2 equals 0.717598 hertz. From there, we take the inverse of the frequency to get the period, and we get 1.3935 seconds. Then we utilize the same function from before, but reverse, in where we get the length is equal to t divided by 2 pi squared times g, which is 1.3935 divided by 2 pi squared times 9.81 meters per second squared. And that gives us 0.4825 meters. Now in here shows what we're looking for. This first pendula we will set to our original length of 0.35 meters. And while the second one, we shift to 0.48 meters. Just to confirm our results, 0.48, good. Now we first pause, bring both up to 20 degrees, bring out a stopwatch, and now as you will see, we'll see how close we get to 8 seconds for both pendula to be back in sync again, which is what I should have mentioned at the beginning. The beat period is how long it takes for both pendula to go back into sync again. As you can see, we roughly got about 8 seconds, so our calculation was spot on. Now, it was hard to get down to the last second because this is a finicky thing, but in the end, the error is worked out, so it's within an acceptable margin. And the reason for this is that Since frequency and period are inverses, so too is beat period and beat frequency, which allows us to utilize the 1/8 and go backwards to find the second length. Thank you for your time. This has been Lorenzo Perella with Physics 116 in Clark Wellman's class. Have a wonderful evening.